now know the total current flow and the resistance of the circuit. So we will now use Ohm's law formula E equals I times R to calculate for the voltage drop across each resistor. When we multiply the current times the value of R1, we show R1 has a voltage drop of 0.555 volts. When we multiply the current times the R2, R3 equivalent resistance of 70 ohms, we see that R2 and R3 will have approximately 0.39 volts. The actual voltage drop across RE is 0.388885 volts. When we multiply the current times the value of R4, we see that R4 has 0.55 volts across it. When we add the voltage drops together, the sum should equal the power source voltage. The voltage of the battery is 1.5 volts. The voltage drops are added together. We acquire the sum of 1.5 volts, which is the voltage of the power source. Now that we know the voltage drops across each of the resistors in our circuit, we can calculate for the current flow through each resistor in the circuit. We know that the resistors R1 and R4 are series resistors, so they will have 5.55555 milliamps of current flowing through them. Since R2 and R3 form a parallel circuit, the sum of these two currents must equal the series circuit flow. We also know that the voltage drop across both the components in a parallel branch will be the same. Therefore, we will use Ohm's law formula I equals E over R to calculate for the current flow through the resistors R2 and R3. When we divide the voltage drop across R2 by the resistance of R2, it shows that R2 has 2.7777 milliamps of current flowing through it. When we divide the voltage drop across R3 by the resistance of R3, it shows that R3 has 2.7777 milliamps flowing through it. This is because R2 and R3 are the same value. When we add the current flow through R2 with that of R3, it shows that it is the same amount of current which is flowing through the rest of the circuit.